I am converting the whole chapter heat into the form of question and answer. This is part 4. But today we are entering into the numerical problem. First, I'll tell you the equation necessary to solve the numerical problem and then we'll enter into numerical problem. Let's start the question number 75. Prove q equal to m into s into dt. This equation is very important to solve the numerical problem, and so this is maybe one of the important derivation in the SEE examination and other examination. Okay, we know that the quantity of heat contained in a body is directly proportional to the mass and temperature of that body. Now this can be written in terms of equation like this: q is directly proportional to the mass. This is equation 1. And next is q is directly proportional to difference of temperature dt. This is equation number 2. Now we can combine these two equations this way. Combining equation 1 and 2, we get q is directly proportional to mass into dt. If physical quantities are proportional to each other like this, then there must be a constant which involves between them. We can change this proportional sign into equal to sign, but we have to take that constant which involves between this quantity. That's why I can write this way: q equal to s into m into dt. S is taken as constant. S is a constant which is called specific heat capacity. Now writing the same in systematic way, q equal to m into s into dt. Usually we write this equation m into s into dt. Okay, this way we can say it is proved now. This equation we are going to use many times while solving the numerical problem. Now next, write the relationship between heat gained or lost by an object with its mass. Now we can write this way: according to the heat equation, q equal to m into s into t, or we can say dt also. That dt means difference of temperature, t means temperature. Whatever we need, we can use that. It means quantity of heat lost or gained by a body is directly proportional to the mass of the body. We are concerned just with mass only. If a body has more mass, it requires more heat to raise its temperature, but if it has less mass, then it gains less amount of heat to raise its temperature to the same value. In the same way, a body having more mass will lose more heat to cool down, and a body having less mass will cool down to the same temperature after the loss of less amount of heat energy. This is the relation between quantity of heat gained or lost by an object with its mass. Okay, next, write down heat equation and mention the meaning of each symbol. This is heat equation which we have proved just before this. Q equal to ms dt, where q is quantity of heat. We have to remember this. M means mass, s means specific heat capacity, dt means difference of temperature, or we may have only t also, which represents the change of temperature. Next, what amount of heat energy is required to increase the temperature of 25 kg of water by 40 degrees Celsius? Now we are entering into numerical problem. This is numerical problem and very simple. What is given in the problem, we have to write first difference of temperature. It means 40 degrees Celsius is the increase of temperature, and this is taken as difference of temperature dt equal to 40 degrees Celsius. Another information given: mass of water m equal to 25 kg, but we are talking about water. That's why specific capacity of water, we must remember, it is 4200 joule per kg degree Celsius. Whether this value is given in the question or not, we can take it. We have to remember this. And heat required, quantity of heat, that means heat required equal to question mark. Now we are using the same equation, q equal to m into s into dt. Now we have to take the value. Q remains same, and in place of m we are writing 25 kg. In place of specific heat capacity s, 4200 joule per kg degree Celsius. In place of dt, 40 degrees Celsius. Here degree Celsius cancel each other, kilogram cancel each other, and this number multiply each other, and our value, final value is 4250 joule. This is very big number. Normally we are not writing this type of big number. In place of this, we express the same number in terms of power of 10. Here we have decimal point at the end, and this decimal point should be shifted to this place because we are taking decimal point after one digit. That's why decimal point is shifted from this point to this. And how many digit left hand side it is shifted? 1 2 3 4 5 6 digit left hand side. That's why we can write this number in terms of power of 10 like this, 4.2 into 10 to the power 6 joule, because the decimal point is shifted to 6 digit left hand side. That's why 10 to the power 6 multiplied by 4.2 gives the same value, 42000050. Okay, finally we got answer, and this can be represented by a sentence. Therefore required heat energy is 4.2 into 10 to the power 6 joule. Okay, next question. Pooja needs 15 kg of water at 38 degrees Celsius to take a bath, but her water is only at 20 degrees Celsius. Calculate the minimum amount of heat energy she requires to heat the water to the required temperature. Now we have to write the values which are given in the numerical problem. What are they? Mass is given. Mass of water is 15 kg. It is denoted by small m. And initial temperature of water was 20 degrees Celsius, and this is represented by T1. Initial is usually represented by T1 and final is represented by T2. This is my suggestion. Okay, final temperature T2 equal to 38 degrees Celsius. Specific capacity of water is not given. We can take the value 4200 joule per kg degree Celsius by ourselves. And next is quantity of heat absorbed. How much heat it absorbs to go to 38 degrees Celsius from 20 degrees Celsius. Q is equal to question mark. Now our equation is Q equal to m into S into dt. Now certainly dt means final temperature minus initial temperature. That's why mass m is 15, S specific capacity 4200, and difference of temperature T2 minus T1. In the process, we can ignore the units of different physical quantity. It's not necessary to write. If you feel comfortable, then you can include the units also. Otherwise, it is not the necessary part of the numerical. Okay, next. 15 into 4200 into T2 is 38, but T1 is 20. And when we multiply 15 with 4200, we'll get 63,000, and 38 minus 20 equal to 18. And if we multiply all this, then we'll have 1134000. This is also a big number. We have to express this in terms of power of 10. That's why point which is lying at the end here should be shifted to this place after one digit. Now how many digits we are going to shift? 1 2 3 4 5 6. Again we are going to shift the point to 6 digit left hand side. That's why we'll write 1.134 this way, 1.134 into 10 to the power 6 joule. If we shift the decimal point towards right hand side, then 10 to the power negative value. If left hand side, then 10 to the power positive value. Now at the end we are writing one sentence for our answer. The amount of heat energy required is 1.134 into 10 to the power 6 joule. Okay, next question. An iron ball of 4 kg mass is cooled from 20 degrees Celsius temperature to 10 degrees Celsius. How much amount of heat is released? Specific capacity is also given. Specific capacity of iron is 460 joule per kg degree Celsius. This numerical is a little different than other because here heat released is asked. Okay, the given is mass m equal to 4 kilogram. Iron ball is a 4 kilogram. Next given is specific capacity 460 joule per kg degree Celsius. Another given is initial temperature which is 20 degrees Celsius and final temperature 10 degrees Celsius. Now what we are going to find out? Quantity of heat again. Here difference of temperature is T1 minus T2. 20 degrees Celsius minus 10 degrees Celsius. Difference never be negative. That's why it is 10 degrees Celsius. Now we have Q equal to m into S into dt. or Q equal to, in place of M we are writing 4 kg and S 460 joule per kg degree Celsius, and difference of temperature is 10 degree Celsius. We are going to multiply all the numbers, and degree Celsius cancel, kilogram cancel, only joule is left, and therefore the final answer is quantity of heat release is 18400 joule. This is not so big number, that's why I am not converting this into power of 10. It is 18,400 joule. Next, a pressure cooker has mass 4 kg and temperature of 30 degrees Celsius. If specific capacity of pressure cooker is 1000 joule per kg degree Celsius, it means the material with which it is made, the specific capacity of that material is 1000 joule per kg degree Celsius. What will be its final temperature when 80 kilojoule heat energy is supplied to it? Okay. Now let's enter into the numerical problem. Quantity of heat is given, it is 80 kilojoule. Kilo means 1000 times greater than joule. Multiplied by 1000 becomes 80,000 joule. And mass is 4 kilogram m. Another initial temperature T1 is 30 degrees Celsius. Next information, specific capacity is given 1000 joule per kg degree Celsius, and final temperature T2 is the question. Now we are using the same equation. What we have, Q equal to M into S into dt, and in place of Q I am writing 80,000. This is equal to M is 4 and specific capacity S is 1000. dt is T2 minus T1, final minus initial. Final T2 we are going to find out. Now we have to go through numbers only. Now 80,000 is equal to 4 into 1000, 4000, T2 minus 30, and if we divide this 80,000 by 4,000, then we'll get what? We'll get 20. And here in right hand side T2 minus 30, and if 30 is taken to left hand side it becomes positive, and that's why T2 is equal to 20 plus 30, and therefore T2 is equal to 50 degrees Celsius. It means final temperature is 50 degrees Celsius. We can solve this way. Let's go to another question. Now I am going to tell you something other than the numerical problem. What do you mean by principle of calorimetry? This is the principle. Calorimetry. What it means? It means according to the principle of calorimetry, when two substances comes in contact, then heat lost by a body is equal to heat gained by another body. No matter both of them are solid or liquid or gas. Just for example, a hot iron ball is dropped into water. Maybe the liquid and solid are mixed with each other. Then what happens? One of them loses heat energy, another gains heat energy. The hotter one loses heat energy and the colder one gains heat energy. Heat transfer from hotter body to the colder body, a body having high temperature to a body having low temperature. But how much heat energy is lost by the hot body is equal to the heat gained by the cold body. This is the principle of calorimetry, and in equation we can write this way: heat lost equal to heat gain. Okay, why we are learning about this? Because there are some numerical problem in which we have to use the principle of calorimetry, and we are going to solve this problem. An iron ball of mass 5 kg at 100 degrees Celsius temperature is dipped in water of mass 10 kg at 20 degrees Celsius. Find the final temperature of water and specific capacity of water and iron are 4200 joule per kg degree Celsius and 470 joule per kg degree Celsius respectively. These informations are also given. This is distinctly two cases. First is hot iron ball, second is cold water. Now we are going to find out how much heat is lost by hot iron ball and the same is gained by cold water. That's why first, in case of hot iron ball, let's talk about its mass. Mass M1 is equal to 5 kg. Why I am writing M1? If mass of hot body is taken as M1, then mass of cold body can be taken as M2. In case of hot, we will take M1 S1 dt1. In case of cold, we will take M2 S2 dt2. In case of cold water, mass M2 equal to 10 kg. Now next, initial temperature T1. T1 means the initial temperature of what? Iron ball, 100 degrees Celsius is given. Initial temperature of T2. T2 means cold water. It is how much? 20 degrees Celsius. This is given in numerical. And next is final temperature. Let's say we don't know. It is T. And here final temperature is the same T, because at last both of them attain same temperature after gaining and losing the heat energy. Now next, heat lost is equal to M1 into S1 into DT1 in case of hot iron ball, but in case of cold water heat gained is equal to M2 into S2 into DT2. What amount of heat will be lost by hot iron, the same will be gained by cold water. Okay, now I am writing the value. M1 is 5 kg, S1 is 470 joule per kg degree Celsius. DT1 means T1 minus T. Here also 10 into 4200 into T minus T2. Final temperature is T. If it is so, then initial temperature of hot iron ball is greater than this final temperature T. That's why T1 minus T is the difference of temperature in case of hot iron ball. But in case of cold water, final temperature is T, which is greater than its initial temperature T2. That's why the final temperature T minus T2 gives the difference of temperature in case of cold water. This is the key point. Okay, let's go to next. When we multiply this, 5 into 470 will get 2350, and T1 is 100 and T remains same. In second case also 42,000, T minus value of T2 is 20. Now according to the principle of calorimetry, heat lost by hot iron ball, which is here, is equal to heat gained by the cold water, which is here. And that's why these two equations are equal. That's why heat loss equal to heat gain, and 2350 into 100 minus T is equal to 42,000 into T minus 20. Now we have to just multiply and divide, and we have to open this bracket also. And next step, we can write 235, this 0 and this 0 I cancelled these two, and next step we can go like this, 235 multiplied by 100 multiplied by T, and here also we are opening the bracket. And then next here, if minus 235 T is taken to right hand side, 4200 T minus 235 T, and if this negative value is taken to left hand side, then we will have 84,000 plus 23500, and adding all this in right hand side we will get this, and left hand side this. And next, if this 107500 is divided by 4435, then we'll get the final answer. It is 24.24 degrees Celsius. That's why we can write one sentence for our answer, that is final temperature is approximately 24.24 degree Celsius, because after this two digit or the third fourth digit is cancelled or it is not taken. Okay, next. If a heater with power 1000 watt gives 36 into 10 power 6 joules of heat energy in 1 hour, what will be the temperature raised in the 50 kilogram of water with temperature 30 degrees Celsius by that heat? Space heat capacity of water is 4200 joule per kg degree Celsius. Power P is equal to 1000 watt. Heat energy H equal to 36 into 10 to power 6 joule. Mass is given 50 kilogram. Initial temperature T1 is given 30 degrees Celsius. Final temperature is the question. We have same equation. We can write H equal to M into S into dt, and this is equal to S is given 36 into 10 power 6 joule, and M is given 50, S is given 4200. Whether it is given or not, we know this, and T2 minus T1. And here T1 is also given. In next step I am going to write T1 also. Look at this, T1 is 30 degrees Celsius. Now we are going through solution. This 21 having 40 is if taken to left hand side, joule per degree Celsius into T2 minus T1 is T2 minus 30 degrees Celsius, and this is if taken to left hand side, then this number should be divided by this, and we'll get what, 17.14 after division, and 30 here negative number. If it is taken to left hand side, then it becomes positive, and T2 will be 47.14 degrees Celsius. That's why what can we write? Therefore final temperature is 47.14 degrees Celsius. Have you noticed this? Instead of writing Q, I am writing here H. Sometimes we write H also. Q equal to ms dt can also be written as H equal to ms dt. H means heat, Q means quantity of heat, same thing. And second point, you have to take care about this also. Here power of heater is not necessary because this much heat energy is already given. That's why this much heat energy we are going to use in the numerical. So power of heater is not in use in this numerical problem. Okay, this way we can solve the numerical problem. Next class also I'll solve some numerical problem which makes you very comfortable in the numerical problem. This much for today. Okay.